Joel, we have spent some time figuring out how to read a mini-tab. In order to do that, we looked at the line distribution observed, and we found in our calculator the expected values, and then we did a couple components by hand. Then we looked at the mini-tab and tried to figure it out. So the mini-tab had all these numbers for it. Can you get it in screen?
Yeah.
All right. All right. So do you have it labeled?
Yeah.
Slightly?
Yeah.
Okay. So on the mini-tab, we saw values that were all around these 9 spots. And it turned out the first one in each spot is observed, the second is expected, and the third is the component. So that if we need to use that on our tests, we know how to do it now. We're going on now. Look at our homework. It was the McDonald's. So Dan, do you recall what the scenario was?
It was about, the question was, do these data provide convincing evidence of an association between the exclusive territory clause and business survival?
Right. So do you recall what exclusive territory was talking about?
Exclusive territory.
It's just that if you buy a franchise, no one's allowed to open a McDonald's near you. So that should help you with the success, because you don't have as much competition. So they set up the data, and we're going to find out if it's an association between the two or not. All right, so if you're asked to do a test, what's the first step always? How's that start with our test? Shannon?
First you have to, well, do real first.
Right, okay, so let's go as far as we can on real. Shannon, take it away.
Well, it's random.
All right, it mentions random.
So you say check.
Okay, so then, what's the next one?
Then you have independent, and I did 170 times 10 is less than all of the McDonald's. So I said check to that.
Okay, I did the same.
And
so
then
that's a check. And now this one, we have to
the L you have to wait to find the
right.
expected.
All right, we're going to come back to that one. So, were you successful in putting this into your calculator and checking the expected values? All right, since I had you replace it a minute ago, it's probably not there any longer, but all the expected values were greater than 5 or greater.
Yes.
Greater than or equal to 5. So there we go. All right, let us look at your hypotheses. Can you take it a step further? So Kevin, what did you say for your null hypothesis? This is an association test. Remember, we've had 3 chi-squares. What are they, Maddie? 3 different tests.
Oh,
This is
the association, obviously. Hang on.
Oh yeah, the pants test.
GOF. The
Yeah.
what is that? Goodness of fit test.
Yeah, goodness of fit. And
And
what's that long word?
Homogeneity.
Homogeneity. So we're in association.
Does
So,
it fit? Yes.
Kevin, how would we start with our null hypothesis when we're dealing with that third test that we learned?
There is an association with territory.
There is?
There is.
Now remember the first one, the null hypothesis is always, how do we used to say it?
A statement of no difference.
No difference. So there's no difference.
There is no association.
There's no association. There's no association between exclusive territories and success. All right. There's another way to say that. Can you say the same thing using the word independence, Andrew?
You can say that the exclusive territory and the survival of the business or the success are independent
Right. So you may
variables.
say it that way as well.
Okay.
All right. So I'm not going to write both up, but be aware that it's also okay. Yep.
I didn't even
All
read
right.
it.
And so then, Kevin, what's the alternative?
There is.
All right. Okay.
Association.
All right, another way, I want to bring this up now, and that is, before, the test likes to mess with this, and I try to keep it all the same when I'm teaching it, but there is like a third way that you can say that, but it shouldn't. It's sort of like, remember when we used to have two proportions? We would say proportion 1 does not equal proportion 2, or what was the other way?
Proportion 1 plus proportion 2 is
And that's another one. Proportion 1 minus proportion 2 equals 0. So remember that one? So it's coming off of that same idea, so you won't be too shocked. But there is another way we could say that. So take a note on that on this homework sheet. It says the distribution. The distributions are no different.
So is there one on the test that says it like that?
What's another way I could say that? The distributions are the same. The distributions are no different. The distributions are the same. So those are all possibilities, and then you have independence as well. All right. Just be aware of that. You have that down. I want to erase it so it doesn't look so confusing.
Wait,
That's Miss Armstrong.
she's here. There's someone in Miss Miller's office. I think
So let's go on.
girl.
What was chi-squared? What did it point to your chi-squared value? And your p-value. It's okay. What about you? Where's your chi-squared for that one? Very good. All right.
Find it.
Okay. Where's your chi-squared?
I don't know where
It's that, that's it.
Yeah, that's your p-value. Write down your chi-squared. Okay.
Yeah.
Good.
Where they
What's your chi-square? Chi squared? But I don't see what's pay.
Okay. Very good. All right. So I'm seeing chi-squares. 5 point.
When you're trying to find chi-square in your
9,
calculator, it comes up chi-squared
and
equals
p-values, so 0.015. So Bree, will that lead us to reject or fail to reject?
Reject.
Because?
Because it's less than alpha.
Pardon?
It's small. It's less than alpha.
No, it's greater than alpha.
What?
No, they give us an alpha of 0.01.
That's right. They
Oh.
switched it up. So I forgot. Thank
Wait.
you, Maggie. Back to you then, Bree.
Oh,
They
It said that?
switched alpha
Yeah.
on us.
Oh, I didn't even see that.
See
All
that.
right, so now-
Yeah,
So we're gonna fail to reject.
Okay, so go back and change that. Fail to reject. There's not enough evidence to say that.
I didn't
there
even
is an
catch that.
association.
It's underlined too.
somewhat underlined.
Somewhat.
So we fail to reject H sub O, there is...
Not enough evidence to say that there is the association.
All right.
Okay.
Okay, so that was, you would have had it right if it was 0.05, but it was 0.01. I forgot that as well.
Wait a minute.
0.01 is
Sorry.
lower than 0.015.
Since when is that American flag there?
There we go. We have an announcement?
No,
Oh,
it's that
okay.
magnet. It's always...
All right.
The magnet. It's usually on the.
All right,
It's usually
before
over
we
there.
end, I want you to look at the last page
Oh, no, that's
of
good.
this handout, where we can look at the top. Those are your observations. We have living arrangements for kids the age 19 to 22. Some live in their parents' homes, other person's home, their own place, group quarters, or others. Group quarters is where you share apartments with others. All right, and then you have the expected values below. So they gave you all the data, you don't have to put anything in. What is the problem that you see when it's actually circled? What problem do we see on this one?
Smaller than 5.
All right, Maggie, what is it?
The expected value.
All right, so it wouldn't pass real. So I told you a while ago that I have a little trick up my sleeve. So I'm going to pull it out and teach you what you can do to help a problem for, pass real. And when we have 3.44 for the other arrangement and 19-year-olds and 20-year-olds, the other arrangement at 4.88. Those two expected values that are circled are too low. They are not greater than or equal to 5. So what we do is we take the 19 and 20-year-olds and we collapse the columns. So we're going to, instead of having 19, 20, 21, and 22,
We'll make one
we're going to
column.
make we're gonna make one column out of the 19 and the 20-year-olds.
Okay.
Can we do the same thing for 21 and 22?
No, because they
fine.
passed.
They good.
Alright, so we have 19 and 20 we've combined, 21 and 22 remain uncollapsed. We collapse them. When we do that, look down on the mini tab and tell me what the expected value is now that they've collapsed the two columns. Look at 19 and 20-year-olds and look where it was a problem. So Morgan, what numbers are showing up now as expected values for 19 and 20-year-olds?
So now for 19 and 20-year-olds, we get the 8.32.
It is. See, were you going to say that? You have to go down where the column says 19 or 20, down to number 5. The observed is 7. Where'd that 7 come from? They added the 5 and the 2. And so the observed, the expected is 8.32. Now it passes. So that's a little strategy.
So they just added those numbers together?
Sometime. Right. All right.
Wait, when you do expected value for that, do you also combine the numbers, or do you have to like?
Well, you don't
Combine
add
them.
them. You don't add them.
So combine these two and then do expected value?
Right.
Okay.
So you'd have to go back and do the row column divided by, multiplied by the column
Is it all
total
just
divided by the
addition?
total.
Yeah. Well, you have to do you have to add the 19 and 20 first and then do the expected value. You can't add the expected value.
They did it for us.
Yeah.
So it was above 5. That's all we cared about.
But they did add it. 3.44 plus 4.88 is it 8.32?
Yeah.
So you can just add the
Yes.
Ask for a card for this.
I did not know that.
Wait, what did you suggest?
Joel, we're
Go
using a
back
brand new
and just
tripod.
redo
It's
it.
way better.
You know,
Yeah, combine the 19
taller.
and 20.
I put all my
Column
review cards
times
through the washer and
the
dryer. They're
column,
gone.
the row total
Oh, I actually-
times
In
the
the
column
group chat.
total.
But you don't
Miss Pell.
Why?
Divided
You know,
by
Mono
the
keeps him
total
from
total.
looking
I
at
didn't
the
think that
roll.
would be the
Yeah, but
same.
why would it be different?
No, it doesn't, because I see his
Just
horrifying
mathematically, I thought
Bitmoji.
it would be.
Miss Pell. Did you have extra of the review cards? I need the first 2 again.
Why?
I
Really hard
I'm
for
pretty
me to
sure
make 'em, but I will.
No, I'm sorry. I'm pretty sure I know where they are, but I'm not 100% sure.
We'll check first.
Okay.
Okay.
Brian, you should also ask because I just asked for
Let's
ask
start
for
reviewing
more.
and we'll see how we feel.
Tell her why.
So I cut up my cards, right?
Yeah.
And I had them in my pocket, but then I did my laundry.
Oh no!
I'm
Okay, you definitely need it.
very
Which
sorry.
all of them?
All of them except the third sheet.
Alright, so A and B.
Yes, and
Okay.
they're still kind of partially intact, but they're all curled up like.
Alright, so Andrew, you check and I'll
Yeah.
try to find yours. We're not gonna do the cards, we're gonna be reviewing today. So, let's go and work together. I'll give you little pauses to think before we dive in, but let's work together through this. This is a chi-square test for association. Maddie,
Oh,
what were
yeah.
the other 2?
Goodness of fit.
Alright,
Pants.
Take a screenshot, Joel. No.
Homogeneous.
alright. Goodness of fit is when we're dealing with a one-way chart, like with M&M colors, and the company has made a claim, and we're testing that claim. Homogeneity is when you have 2 samples or more with 2 characteristics or more, and it ends up in a two-way chart. And this is the third. A chi-square test for association yields 9.14, so that's your chi-square value. And the scenario is you have colors of cookie packages, red, yellow, orange, green, and brown. And you're comparing that to the success of whether they meet their sales goals or not, yes or no. So find and interpret the p-value. Alright, and I also asked you to establish a null and alternative hypothesis and make the appropriate conclusion. Alright, there are 2 ways. You don't have to write both ways, but at least be able to tell me both ways. Alright, so go ahead and see if you can take your chart out and find the appropriate p-value.
Is this written down somewhere? Oh, it's on this.
Yep, it's written down.
Wait, what?
If you don't have your individual chart sheet, it's in your back of your book. I'll provide it for the test. I don't have any extra right now, but your book has it.
Shouldn't we do H sub O and H sub A first?
It's up to you.
Okay. Do we know what DF is?
Yeah, it tells you the categories.
You have to figure that
Oh,
out.
okay, yeah, that's right. I didn't see the categories.
That's part of the
Yeah.
problem.
Wait.
Miss Powell,
Uh-huh.
on the test, is it gonna say what test it is looking for?
Usually not, but there's
How
enough
do we know which one it
information to
is?
figure out which one. And one thing is good is that you do them all pretty much the same way,
Yeah.
you know?
It's the difference is more in interpretation.
You can tell by the table whether it's
I don't know what my
Like
chart
this
looks
one
like.
doesn't give you a table, so you kind of have to think of the table.
This one's just the one-way chart, right?
when it gives you a table.
Oh, it's
A
not.
one-way chart.
It says a test for
A
association.
one-way chart is
Oh, okay.
good as a fit, and then
So with success, yes or no? Does it meet the sales goal? And then the color of the package, so. All right, so, was this yours? All right. The null hypothesis then, when we're dealing with association, is?
There is no association.
All right, no association between color of packages and success of sales goals. So, I'm not gonna write that on the board.
Wait, can we also
Yeah.
say difference?
Pardon?
Or we're not, that's not how. This is an association.
Yeah, difference.
I
is a
mean,
different
could you
thing,
say
I think.
difference? No,
Pardon?
no, it has to be association.
No, difference is different than association.
You can say the distributions are, if there's no association,
I said
what's
there's
gonna
no
happen to the
difference in-
what's
said
gonna
there's-
happen to the distributions if there's no association?
I said there's no difference in the distribution of the color of cookie packages.
All right,
Is that right?
yeah. All right, so I know association is clear, but I like it that, I like to be able to go both ways. And then there's the old independence way. So how can we say that one? Andrew, you were good at doing that. How can
For
we use the
H-
word
H sub A or H sub
O.
O? Okay, the color of packages and success are independent variables, I guess.
Okay, that's good. So it's saying there's no association.
Right.
All right, so if you got H sub O and H sub A then, how do we go from there? We've got chi-squared, so H sub O says there is no association. I'm not gonna write the rest. And H sub A, there is. All right, so how do we go from there? To use the chart, what else do we need to know, Kevin? We've got chi-squared. So what do we need to know before we can completely use the chart?
We're good. Can we not just use it now?
All right, we'll look at the
No, we need to know
chart.
degrees of freedom.
Right, degrees of freedom. So Kevin, guide us on that.
We have 5 different columns or rows. Subtract 1. We have 4 degrees.
All right, so 2 minus 1 times
Oh, it's that one.
5 minus 1.
2
So
minus
we have
1 times-
2 minus 1, columns minus
Wait,
1.
what?
Rows
Oh, I
minus
forgot
1.
it's not that.
Wait, we have
Yeah,
to-
it's different.
Is that
No.
is this just for association?
you do.
Oh, it's still 4 though.
2 minus 1. Right, okay, you didn't say that.
Calm down.
What?
2 minus 1 is 1,
Miss Powell,
Kevin.
is this just for association that you have to do rows and columns?
Yeah,
Or is
2
it-
minus 1 times.
Is it
the
just
5
for
minus- she
association
didn't-
that you have
she
to
said-
do
she said 2 minus-
the degrees of freedom row times degrees of freedom column?
Or is it
Or
just
is
with
that-
the
You have
two-way
to do it.
charts?
You have to do it all the time.
Wait, I thought that was
Always?
just for,
I feel like
you
we've
have to
never
do
done
that for
that.
we didn't do that for goodness of fit.
Yeah.
No, I thought
Yeah.
it was for
It
just for two-way
It was
charts.
just the number of categories
Isn't it
minus
just for
1.
two-way charts that you do?
But this is a two-way. Well,
Yeah.
how? So
No, they're just asking. They're not saying that you shouldn't do it now. They're
Yeah,
asking which
we
ones.
we
Like,
didn't do this earlier for goodness of fit.
Yeah. Well, good as a fit, we only had one set of values. Like we had M&Ms that were red, blue, green. So we only had number of categories minus 1.
So goodness of
It
fit.
was always a one-way chart. So
Goodness
we
of
didn't have
fit.
like 2 by.
Same answer.
So a two-way chart, you do have to do it.
Right.
Okay.
Yes.
So okay,
So
only
you
for
do it
two-way
for
charts.
homogeneity and association,
Yes.
but not for goodness of fit.
Right.
Okay.
You
So
won't
the
even run
difference
into
in
that
goodness
problem
of
'cause when you
fit
have
is
a
just
one-way
number
chart,
of
you have two
categories
ways to
minus
put in the
1.
equation.
All right.
Which
So
would be
let's
a
go on
1 minus
and do that then, Kevin, on your chart C. What number comes up for your p-value?
We comes up with
Or what
between 0.05 and 0.01. I mean 0.10.
all right, so 0.05 to 0.1, somewhere in there. So if I am confused
this
about
could
the
get so much
0.05, I actually go to the
Like 3 times this,
calculator
'cause there's 2 more
and find it that way. So since 9.014, was that right on the 0.05 column, or was it just toward this number?
It was more to. It was pretty close to 0.05.
It was close,
Yeah.
but larger?
Yeah.
All right, so probably 0.05 is a bookend, but it's not going to be 0.05 if the number, the 9.14, was in between these two numbers. So I kind of ignore 0.05. If I'm confused, I look it up on the calculator. So I'll remind you how to do that. Second bar,
Wait, it's
chi
point.
squared, CDF,
It's 0.05 minus 0.1.
now 2,
It's supposed to be like a comma.
Okay, sorry.
in between,
Yeah.
somewhere
Yeah, that's what
in
I was
there.
gonna say.
So, since I'm trying to compare it to 0.05, it gets confusing because 0.05 is in one of the possibilities.
So,
So I'm going to check with the calculator.
Your D
Second
is
bar
upside
is
down.
chi squared
D is
CDF.
upside down.
What's that?
You said your D was upside down.
Yeah, it is CDF, right. Thanks. All right, so then
Chi
you have
squared
to
PDF
tell
or
it the
CDF?
lowest value. So
Right,
remember what a
CDF.
chi squared graph looks like? So the lowest value is 9.14. And we want to know the area past it as well. So we have to have the lowest value, 9.14, comma, the upper value, 1,000. We can go as far as we want.
How did you know the 9.14 is the lowest value?
It's chi squared. Kyber crystal.
Here's a picture.
We
We
please
know what we're doing.
Doing.
And then we have degrees of freedom 4. So someone get that number out of your calculator. What is it?
That number I think. It's 0.06.
0.057.
Yeah, which is 0.06 everyone.
0.057? Alright, so that tells you.
It's actually not 0.057. It would be 0.058 if you guys were good at rounding.
0.058.
So
Alright, so that is above 0.05. So what do we do, Bree? You always tell us? This is above
We
0.05.
fail to reject.
Alright, we fail to reject because it's not that rare.
Yeah.
So therefore, we say there is not enough evidence to say what, Bree?
To suggest that there is an association between the color of cookie packages and the success of meeting salesmen.
Really fast, can we go over when you fail to reject and when you just reject? Just
fail to reject is when it's bigger than alpha.
when it's big enough that you fail to reject.
Correct.
Yeah.
Because there's not enough.
I think of it as like it's big, so we
Okay.
accept it. We
No.
accept it when it's big.
Okay.
We reject. So
You fail to reject.
Number 2. I want you to,
We
in
accept the big
general,
one.
describe the shape of a chi-square distribution. I've got one of them up here for you, but
It's described like straw.
yeah.
Crystal.
Tell me about its features. Describe the shape of a chi-squared distribution. What's the relationship between the mean, median, and degrees of freedom? And
Can we do
where
the
is
card
chi-squared
GIS?
negative? So those are all related to the chi-squared distribution.
The answer is all of them.
So Ryan, how would you describe this guy?
It's always skewed right.
Right, always skewed right. Even when, if you look, remember, when degrees of freedom was at 1, it looked like this, which is very weird.
Number 2,
But
Joel.
even that is skewed right. So his answer is correct for any of them. So it's always right skewed. And does it become more and more skewed or less as degrees of freedom rises?
less.
It becomes more skewed as it gets bigger.
Look at our notes from that day.
It becomes less
Less skewed
skewed.
as degrees of freedom rises.
As degrees of freedom rises, it approaches less skewness. So then it becomes skewed, but not so much.
So as degrees of freedom gets bigger, it skews less.
Right.
Okay.
It's
Small-
still right skewed,
small
but not
skews.
as much. As the
Big.
degrees of freedom goes up,
Big is big
and
skew.
we
Small
have
DF is
graphs
skewed.
in our notes.
BDF.
Review those. As degrees of freedom goes up, skewness
Goes down.
goes down, but it doesn't go away. It's just not as skewed.
They never go away.
All right, I said this wasn't on the test, and I found out it
Well,
was.
for that, I see what's
So there's some fancy ideas. Do you remember the relationship between the mean
It's
and
after
the
the video,
degrees
it
of
says-
freedom?
Sorry, Joel, for that answer or for the rest of the video.
The mean of the graph
Leave the lens
equals the
on.
degrees of
Right,
freedom.
so they did have that in the middle of a multi. So that means, say this is degree, what's that one look like? Degree 4?
The mean
I don't
equals
know.
degrees of freedom?
Let's say it's degree 4. I don't know. Okay, no test tomorrow. So
I used
we'll
to say that
see.
so much.
Woo!
Wait,
Wait, what did you
So
say?
degree
No
of
test
freedom
tomorrow.
is 4. So what would the mean be?
4.
Alright, so if this is degree of freedom, remember how the numbers go across? 0, 1, 2, 3, 4. So that means the mean. Remember the mean is drawn toward the tail. It'll be past the highest point. So the mean is right here. Now if this is degree 8, that means, well, I don't have that drawn like degree 8. But as the degree increases, the mean does as well. They're always equal.
We don't have a note about the median.
Wait, what did we say
Yeah, I
about
remember
the
the
median?
We have a
I
note about the
did.
mode,
Ryan, the strongest.
Oh, really?
I don't
Yeah,
remember the
Ryan
median.
requires
but you never said anything about the
Mode. I have to look
When
at
I'm
that
answering with Taylor.
test. Alright,
So what do
let me see somebody's
Taylor.
book.
She just
Taylor.
Is,
When answering
Just
with
the
Taylor,
mean.
Ryan.
mean of
see
the graph.
somebody's
Wait, let's
book.
talk about equal weighting.
Alright, yeah, talk about, you think about the negative one while I look up the value about the median or the mode. One of the
These
two.
kyber crystals will bless your soul.
Alright,
These
think
kyber
about
crystals-
when it is negative.
These kyber crystals will bless your soul. These crystals.
Think about it for a little bit.
I geeked him.
Is chi-squared
For-
never negative?
But it can be over.
Chi-squared never.
Because on the chart there's no negative.
Yeah, so it has to be positive.
Where do we learn about these chi guys?
Because yeah, there's no negatives on table C, is there?
It says where is it negative? No,
Oh.
Yeah,
where.
here it is.
Nowhere.
Alright, the mean of a particular chi-square distribution is equal to the degrees of freedom. The peak mode, when the degrees of freedom is greater than 2, is
Yeah, that's
is
the mode.
degrees of freedom minus 2. Yeah, we don't have any information about that. Alright, let's change that to the mode, sorry.
Wait, what? Change what to the moon?
Median to mode. And then when the
Alright,
degrees
so
of
what,
freedom.
I just read it, did you hear me, Bree? How's it work with the mode?
Okay, so if you're looking for something, if it's greater than 2, you take the degrees of freedom and subtract 2 from it.
Right, but you can't, it won't work.
If the mode is
degrees
greater than
are-
2?
If the degrees of
Degrees of freedom
freedom,
is greater than 2, then the mode equals degrees of freedom minus 2.
yeah, you have it in your notes.
Okay.
Degrees
Alright.
of freedom is greater than 2.
Greater than 2.
Okay.
Then the
If
mode
DF
equals the degrees of freedom
Why
Yeah.
does degrees of
minus 2.
freedom have to be greater than 2? Yeah, because you can't
What up,
can't
it's your
subtract
boy,
2 from it otherwise.
Is chi-squared
What up?
never
It's your
negative?
boy,
We'll get to
Cabo
that
Crystal.
next. Alright, you got that for your
Skinny Crystal.
mode?
Yes.
Alright, now the degrees of freedom compared to, oh no, that's it. Where is chi-squared negative? It is not
Nowhere.
negative. So notice here,
Yes.
it's 0 at the beginning, but that doesn't count. And notice the chi-squared is 1, 2, 3, 4. It doesn't work like the normal curve or the T distribution.
Kyber crystal.
Alright, number 3 should go quickly. For a 5x4 two-way table, what are the degrees of freedom? Can you talk me through that one, Dan? We have a two-way table
Oh, I know.
that has 5 rows and 4 columns.
See, he know
So
he
how would I get
columns
the degrees
and
of
he rows.
freedom, Dan?
Are you sure it's... I'm pretty sure 5 by 4 is means column by row.
Yeah.
Because
Row
in my
by column.
calculator,
Oh, no, yeah,
in
it's
my
row by column.
calculator, it's not.
Yeah, in the calculator,
In the
it puts-
calculator.
the first number means how many it is up and down.
That's rows.
Yeah.
Yeah.
No.
I think you're just confusing what a.
Rows.
No.
Hold on.
Wait.
Think like
Columns are up and down,
Yeah.
rows are across.
Yeah.
So when you do
Like
a
rows of
5,
seats.
when you do a 5, Shannon, it adds more on the bottom.
So that's more
More
cross.
rows.
No, that's
More
column. No, yeah, that's more rows. Yeah,
bigger
yeah. Okay.
Columns get bigger when there are more rows.
He right.
Columns
Rows get bigger. Rows get longer.
Rows get longer when there are more
Columns are
columns.
the amount of numbers that are across the top. Rows are the amount of numbers that are across the
Columns.
side.
Yeah.
All right, so
Rows, and so when there are more rows,
There's gonna be another.
Columns
There's
look
gonna
longer.
be columns
Yeah.
will be bigger.
but there are still the
Just
same
like
number of
columns.
columns.
They're still same. You can add as many
Rows
rows
is
as you
how
want and
many
have the same number of
stripes in your
columns. It'll just be a
flag?
bigger column.
and columns is how many columns? Like a column. Right.
One by one.
Like
Yeah, Daniel, we got it.
No,
Daniel, just answer Miss Powell's
column
question.
that fell over.
Answer Miss Powell's question.
two
by-
by-
Daniel.
All right.
Hey, Drew.
2.5.
That's 2 by 0.5.
One by
Oh yeah,
Dan.
1.5.
Dan.
1 by.
1 by 2 and 1 by 1.
Yes.
All right.
How many
Question.
degrees of freedom?
It would
5
be
rows, 4
It would
columns.
be 5 minus 1 times 4 minus 1.
Which is?
Which is 4 times 3, which is 12.
Right. That's a lot.
Erase your.
Quick
erase
math.
your gun with the
All right, we had some math. What do you think?
You had to
All
do
right.
the.
We're
Wait.
pretty much out of
But you
time,
did. Miss Powell.
So we're gonna finish this for homework.
But you
You'll
didn't-
see-
Sorry, I have. So we decided that for a golf test you do df minus 1, and for the other two you use that formula. But we don't know which test we're running, so how did he know to use the formula and not?
You have
It's
to-
a 5 by 4 table. It has to be 2 ways.
Yeah, that has to be 2A, it can't be.
Oh, okay. So because Homo and Asaka are two-way charts.
Right.
Okay.
A sock. I
Yeah.
like that. All right, Joel. Hope you're
I don't.
keeping up with us and getting well.
Wait,
So,
are we
see
having
you
this
later.
tomorrow or on Monday?
Monday.
Monday, but this is homework.
Finish the review of
One,
homework.
2, 3.
Finishing the sheet for homework.
Daniel, he said.
So you must pay.
Then we will zip
He
through
said